All right, quick video running through the Chapter 1 tests. If you didn't do as well as you wanted to, you can redo the ones you missed on the retake. I'm not going to go super slow on these. I'm going to go rather quick just because we did it in class. But if you were absent or you happened to zone out while I was going over it, you can take a look at this video. Here we go, number one. So I'm trying to add these two radicals. I have to have like radicals. They have to be the exact same number. So I need to break up that square root of 20. So I'm going to have 4 times square root of 5. Well, 20 can be written as the square root of 4 times the square root of 5. You know, I'm looking for those perfect squares. I'm looking for the square root of 4, the square root of 9, 4 times 4, 5 times 5, things like that. I'm looking for those to try to break it up and make it smaller. Because when I do that, this is really just 2. So now underneath I have 4 radical 5 plus 2 more radical 5 is going to give me a grand total of 6 radical 5. So notice that when you have this like radical, you just kind of bring it along for the ride and then just treat these as coefficients in the front, just like as if they were x's. All right, number 2, this is an SAT style question. I don't think it's that tough of a question. It's just kind of awkwardly worded here. So when I look at this, the square root of 16 is just 4. Plus the square root of, I don't know, this is the number that we're trying to figure out, equals, well, the square root of 100 is 10. So basically I have 4 plus the square root of something is 10. So when I subtract that 4 from both sides, I basically have the square root of what, or x, equals 6. So somehow I need to get a 6 there. So it isn't, the answer isn't 6. What needs to go in red for the x is the square root of 36. Because that's what comes out to be 6. So now my equation up here above is true. 4 plus 6 does equal 10 when you do all the square roots. Number 3, this is just combine like terms, simplify. So I distribute 6x, negative 12. Remember that minus is a negative 1. So I get a negative 2x. Then I get a positive 2. Gather up my like terms. I have 4 x's. Negative 12, positive 2, that's negative 10. All right, moving right along to number 4. This one is just I'm multiplying powers. I'm not raising any powers to powers. So first I do 4 times a negative 3. I do my coefficients there. That's negative 12. Now I have a to the third times a to the third, and that is a to the 6th. I add my exponents. B to the 4th times b to the 2nd. That is b to the 6th. And we are all set. Now, number 5, I'm raising a power to a power. So everybody in here needs to get raised. So I have this negative 3. These parentheses are super important. To the 2nd. Then I got to do the x third to the 2nd. Then I have to do the y squared to the 2nd. Negative 3 times itself, well, that's a positive 9. When I raise a power to a power, I multiply. So it's a little different than number 4. And 2 times 2 will give me 4. And we are all set there. All right, next one, number 6. Here's where I have some negative exponents. Remember, negative exponents, if it's in a fraction like this, if they're negative, you got to throw them to the other side and make them positive. It's that simple. And then you're going to do some canceling so that you never have the same letter on top and bottom. That's not allowed. It's not simplified. So first off, let's deal with this 12 over 9. I don't want to put that in my calculator. I just want to reduce this. So 3 goes into both those numbers. So I'm going to have 4 over 3. Well, now when I look at a to the negative 2, that can't be on top. It's got to go on the bottom. And this a to the negative 5 is on the wrong side. This b to the negative third is on the wrong side. It needs to go on the bottom. B squared is okay. It's positive. I'm going to leave it alone. Now I just need to gather up my b's if they're on top or bottom. Here they're on bottom. My a's I'm going to cancel. So on top I have 4, and then these 2 are going to cancel with 2 of those. And I'm going to end up with 4a to the third. On bottom I have 3, and then b to the third times b to the 2nd. that's b to the 5th. That's 5 b's down there. Boom. Moving right along. Back to the top. Here I have a negative power. So I can just do the same thing I did in the last problem. I'm going to do it this way. I'm going to raise everybody to the negative power. So I'm going to raise that 4 to the negative 2 power. I'm going to raise x to the negative 3rd to the negative 2 power. I'm going to raise y squared to the negative 2 power. Well, for the negative 2nd, that's really the same thing as 1 over 4 to the positive 2nd. This next one, x to the negative 3rd raised to the negative 2nd, when you multiply these, it actually becomes just a positive x to the 6th. I'm going to put a 1 under it just because I want all fractions here so I can multiply easier. Well, here I am going to have y to the negative 4th. And so I would write it like this, but I know I can't leave it as y to the negative 4th. So I need to throw it on the bottom and make it positive. I'm going to put a 1 on top. So now multiplying across, I have x to the 6th. On the bottom, I have 16 y to the 4th. All right, number 8, scientific notation. So there's a way that we're going to do this. 2.0 times 10 to the negative 7th divided by 8 times 10 to the negative 9th. What I'm going to do here is I'm going to just first divide 2 divided by 8, and I get 0.25. And then when I divide powers, I really subtract these two exponents. So I'm going to take away negative 7, take away negative 9. But really when you take away, you add the opposite. So that comes out to be 10 squared. Now, this is really close, but to be scientific notation, this number needs to be somewhere between 1 and 10, and it's not. So I'm going to make this number bigger by a factor of 10. I'm going to call it 2.5. Since I made this number bigger, I have to make this side smaller to keep it balanced. So that 2 is going to reduce down to a 1, and there's my answer in scientific notation. Number 9. So this is multiplying. There's an understood multiply here. So I multiply that out, I get 16. When I multiply, I add these two. That's going to give me 10 to the negative 5. 16 is not a number between 1 and 10. So I'm going to do the opposite that I did last time. This time I'm going to decrease it by a factor of 10. So over here I need to increase that by a factor. And that's going to put me at a negative 4, because negative 4 is 1 bigger than negative 5. Some of you made a mistake and went the wrong direction. All right, number 10, this is just vocabulary. What are the following is the domain? Remember, the domain is the x values. So I'm looking for the set with these 4 numbers in it, and it's right here, A. If you picked B, that was the range, which represents the y values. Probably the best wrong answer there. All right, number 11, is the relation shown in the table a function? Yes, this is a function. How do I know it's yes? Because all of the x's map to their own y. You never see an x going to 2 different numbers. So this is yes, it's a function. When I go to the next one, this is not a function. All right, this one is no. Why? Because it fails the vertical line test. You know, lots of places. Right here, it fails because right there, you know, if I analyze the x's, I have x equals 1 going to 2 places. It maps to y equals 1, and it also maps to y equals negative 1. So I have a problem there. The x is cheating. All right, moving on down, number 13. I want to do f of negative 3. So basically, you just rewrite the original function here. And wherever you see an x, put a parenthesis. And then what you put in the parentheses is what's in this parenthesis over here. So I stick in a negative 3. So order of operations says I have to do my powers first. So I have to do this part first. Negative 3 times a negative 3 is 9. And a 9 times a negative 2, that's a negative 18. Positive 3 or plus a negative 9, however you want to write it, it's going to be minus 9. This comes out to be negative 27. All right, number 14, very similar. I'm going to copy down my equation, put a parenthesis where x is, and then I'm just going to drop in what's in parentheses. Here it's more than a number, it's actually an expression. Got negative 2x minus 2 minus 3, don't forget that little guy. That simplifies into negative 2x minus 5. Boom. Keep on moving. We're cruising now. 15. You have some points here. Maybe I'll kind of cheat. I'm going to slide down a little bit so I can, doggone it. I want to use this graph over here to kind of help me out with my points a little bit. All right, so it says we have points, blah, 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 blah. Let me see. I'm just going to kind of quickly sketch out a grid here just to see what's going on. 2, 3, 0, 4, and 3, negative 1. All right, so we have those points, and the coordinates are going to go up 2, left 3. So every single one is going to go up 2, left 3. So you're going to go up 2, left 3. So the new point for that person is at negative 3, 6. Not negative 3, 6. 2 up and 3 left. What did I do wrong here? 2 up and 3 left. Yeah, negative 3, 6. Well, the only one right now I see with a negative 3, 6 is right here. I could verify the other ones. The 2, 3 is going to go up 2 over 3, which is going to be right there. And that one is at negative 1, comma 5. So that checks out. And the last one would check out if you did that as well. There's also ways you can do it with x and y's, but I'm going to just stick with just good old-fashioned problem solving. Moving on down, number 16, a segment with those endpoints is on the graph. We are reflecting across the x-axis. So reflecting across the x-axis. So think about this. This is the x-axis. If I have some point, let's say we have a point living here at 2, 1. Well, if I reflect over the x-axis, that means I jump down here, and I'm now at 2, negative 1. So if you notice, the x value stayed the same, but the y changed its sign. So we need the x to stay the same and y to change its sign. So x to stay the same, y to change its sign. I don't see that one. X to stay the same, y to change its sign. I do see that one. Boom, the answer is C. Number 17, identify the parent function. So the parent function is the largest power. So you go through every term. It's the largest term's power, which is right here. This is x to the first. That's an x squared. Some people added those together and thought it was 3, thought it was cubic. But an x squared is a quadratic. So remember, the cubics are x to the third. Square roots are going to have that in there somewhere. Linears are x to the first. Quadratics are x squareds. Number 18, graph the points below. Identify the parent function. You have to scale it to fit everybody on there. Let's just kind of bust this out really quick. Looks like my x's go from negative 4 to 3. So I'll kind of keep this in the middle. My y's go all the way up to 21. So let's just, I guess, go. We got to go over 3 and then negative 4. 1, 2, 3. Let's just do these by ones. -1, -2, -3. Oh, we're going to fly off the grid here. No big deal. -4. And going up, we'll go by twos. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. 22, I said. All right, let's get some dots on here. So -4, 21. So way over here at -4, all the way up here at 21. -2, 9, zoom, zoom. 0, 5, 1, 6, 3, all the way up at 14. So if I'm kind of connecting these, it looks like we come down and we start to go back up. So that right there looks to me like a quadratic, a y = x² parabola. All right, keep on going. We're almost done. Number 9, we have a function gives the height after t seconds it's thrown in the air. So you could make a table. I mean, if you didn't have a graphing calculator, and I said, hey, you got to do this by hand, you could make a table. T is your seconds, h is your height, and you could plot this out. And first of all, stick 0 in. Well, the height's going to be 0. At 1 second, put a 1 in here. And you could start plotting all those points. Then you want to analyze the table to see A, B, C, D, who's right. We're going to do this using the graphing calculator because it's much faster, it's more accurate, and it's a skill that I need you to know. So let's open this up. Let's get rocking and rolling. Turn it on. Y = clear it out. 16x minus 2x to the second power. Lock it in. Second table. Well, there's our table. And we want to know, is the height at 1 the same as the height at 4? Well, remember, x is the height. And y, so on our graph here, I want you to kind of know this is like the y, and this is the x. So at a height of 1, well, there's a height of 1. Is that the same as a height of 4? No. How about 2 and 5? 2 and 5. No, 24 and 30. 3 and 6. 3 is 30. 6 is 24. No. Hope it's D. 2 and 6. So 2 is 24. 6 is 24. We got a winner. Correct answer is D. All right. Last one. The graph of y f of x is there. So what is the value of f of 1? So x is what's in parentheses. So we know what x is. We know x is 1. Well, f of 1 is really the y value. It's what does the function spit out? It's what is the output when the input is 1. Well, when you input a x = 1 in, it spits out y = 2. So the correct answer here is C. All right, hope that helps. Hope it gets you ready for the retake. See you.